All right, we're going to look at notes for 5.4, solving some more rational equations. And so the way that we're going to do this is we still need to find a common denominator. And so we have 2 that doesn't have a denominator. X plus 1 is the denominator for the other ones. So my common denominator here is just going to be x plus 1. Now, since it's an equation and not an expression, I can get by with multiplying the left and right side of the equation both by the common denominator of x plus 1. And what will happen is it will cancel it out where I don't need it, and where it doesn't have it, it'll add it to that portion as well. Before we do that, though, let's see what things x is not allowed to equal. So 2 doesn't have a denominator. The only other one is x plus 1. Really, we can just look at that common denominator and the pieces of it when we have more than one. For this, since I only have that one piece, the only thing that would make that equal to 0 would be a negative 1. So x cannot equal negative 1. So let's work this out. And the way we're going to do this is I will multiply each piece of those by x plus 1. And so for the 2, I'll do 2 times x plus 1 minus 1 over x plus 1 times x plus 1 equals x over x plus 1 times x plus 1. And so now what we can do is we're going to view each part of these kind of as its own little set. And so we will combine and simplify here, combine and simplify here, and do the same on the end there. So 2 times x plus 1 will be 2x plus 2. Then for negative 1 over x plus 1 times x plus 1, since I'm multiplying, I can cancel those out. That just leaves me with minus 1. The other side of the equal sign, similar thing happens. These cancel out, and I'm just left with the x. And so the great thing about that is that it gives me a nice algebraic process that gets rid of all my denominators. So I'm left with no fractions and only a little bit of combining and simplifying to do. So when I combine like terms here, 2 minus 1 is 1. So I have 2x plus 1 equals x. So then I'm just going to subtract x from both sides, and I'll also subtract 1 from both sides. Those will cancel out, as will my 1's over here, leaving me with just a single x and a negative 1. So x should equal negative 1. That would be where those two meet, where they cross, however you want to say it. The only problem is those are going to be either, if you graph it, you'd see those as approaching infinity or negative infinity at that negative 1. And so it never actually reaches that point, meaning that they won't actually cross. So that's when we do 0 with the line through it, or write no solution, because there is nothing that works for that, because we're not allowed to get a 0 in the denominator. Okay, so moving on to the next one, we're going to do the similar process, but the first thing I need to do is I need to factor out these denominators best that I can. So 2x plus 8, I would be able to pull out a 2 and have an x plus 8. So in that, Your way to check, and that's why I'm saying to check, because I put an 8 there when it should be a 4. So I always think if I multiply that 2 back into it, would I get the same thing? So 2 times x is 2x, 2 times 4 is 8. So good check to make sure we're doing the right thing. Next one, x squared minus 16 is difference of squares, which means I would take the square root of both, square root of x squared, square root of 16. So it'd be x plus 4 and x minus 4. Same thing, you can FOIL those back, multiply them together, do the box. It gets you back to the same binomial there. And the last one, similar to the first, the 2 and then an x minus 4. So for my common denominator, what I always do is I start with the farthest one to the left, and this denominator, I'll put every piece. So 2 and the x plus 4. And then for the next one, I'll put whatever piece isn't already up there. So I already have an x plus 4 up there, but I don't yet have an x minus 4. So I'll put an x minus 4. And so remember, we are just looking at any of these that are in parentheses, and that's why I put parentheses around a lot of things here. When I've got them in parentheses with a plus or minus sign in the middle, those are its own piece. So I don't have an x minus 4 up there. That's why I'm putting that and not considering this to be similar to it, just with a different sign. My last one, a 2, I have up there, and an x minus 4 I also have up there. So going then with our multiplying by the common denominator, I'm going to rewrite these fractions and just leave a little bit of space. So 10 over, and I'm going to write the factored form of the denominator. Remember, once we factor those denominators, we're not ever going to multiply them back together. We're going to leave them separate. 7x plus 8 over that's going to equal negative 8 over 2 times x minus 4. And so next thing I'm going to do is multiply each part by that whole common denominator. You'll see pretty quickly and be able to shorten it that like I have a 2 and an x plus 4. The part that I'm missing is all that's going to end up here with the 10. And the same with the other two fractions. So we'll write out that common denominator for this one, but probably shorten a little bit as we go. Okay, now that I have my common denominators there, and remember, I'm allowed to do this, it's one of my algebraic rules. If I multiply all the pieces on this side by the same thing that I multiply the opposite side by in an equation, so if I were to multiply this side by 2, then it's fine as long as I multiply this side by 2. Kind of the same concept when we take a linear equation in standard form and change it to slope-intercept. You end up dividing by like whatever number would be in front of the y. So dividing and multiplying, we can go through kind of the same steps here. The only part of that I would have skipped is would have had this whole thing in parentheses or brackets. Said, well, I'm multiplying 2 times x plus 4 times x minus 4 times this whole thing. And then it's just getting distributed to each piece. So this is after it's already been distributed to each part. But we'll go along, and since I'm multiplying, I can cancel out. And remember, we'll look at this as its own piece. That's its own piece. And on the other side. So just simplifying within this, because we have that minus sign separating it there. So I have a 2 down here and a 2 up there. X plus 4 and x plus 4. It's going to leave me with 10 times x minus 4. Go ahead and that minus sign. And I have x plus 4, x plus 4, x minus 4 for both. So all that's going to be left is that 2. I'm going to move that 2 up in front just to make it a little less confusing when I distribute that negative and the 2. That way I'm not distributing the negative from one side and the 2 from the other. So all that's left up there was the 2 and then the 7x plus 8. Just carry that negative sign over. Then here I've got a 2, x minus 4. And so I'm left with a negative 8 and x plus 4. Okay, and one of the things I've done is gotten a little ways along without getting what x is not allowed to be equal to. I try to do that at the beginning, unless I happen to forget for a little while. So let's look at, I could look at each of these pieces, but really the common denominator has all 3 pieces. So looking at each part, whatever would make it equal to 0, x cannot be. So the 2 is fine on its own, but I've got x plus 4 and x minus 4. So what that tells me is x is not allowed to equal a negative 4, and it can't equal a positive 4, as either one of those would make this one or more of the denominators equal to 0. Okay, continuing on with our problem here, I now need to distribute, and all 3 of these have some distributing going on. Remember to keep that negative with the 2, and the same with the 8. I end up with 10x minus 40 and a negative 14x minus 16. And all of that equals a negative 8x and a negative 32. We'll do some quick combining. 10x and a negative 4x. So that's just splitting these up to combine. 10x minus 14x give me a negative 4x, negative 40, and a negative 16 would give me a negative 56, and that's going to equal that negative 8x minus 32. So I will, on this, I can, since there's just one x value, or x to the first power, I can move the x's to the left side, the coefficients to the right side, or the whole numbers to the right side, and solve from there. So negative 8x would be a positive 8x over here. Negative 56 turn into a positive 56 over here. So those have both moved. And I end up with 4x equals 56. Looks like that equals 24. So when I divide by 4, 4x divided by 4, 24 divided by 4, it's going to be an x value of 6. So I'll check. It's not allowed to equal negative 4 or 4, so I am in the clear for that one. X equaling a positive 6. So a few steps there, but mainly this is just solving out the equation, canceling out common denominators. So let's look at one or two more. On the one I've got here, I've got an x minus 1, a 3, and an x minus 1. So my common denominator, I've got an x minus 1, My 3 there, it does not have. So let's put the 3 up front. So 3x minus 1. And don't have any, just already got an x plus minus 1 there. And the only thing it's not going to be allowed to equal is a positive 1. So I'll do the same thing here with my fractions, multiplying them by the common denominator. Remember, we're not going to combine any of those because really our goal is to cancel some stuff out. And so as I work through this, x minus 1 and x minus 1, giving me 3 times x plus 1 is going to equal, I have 3's that cancel out, give me x times x minus 1. And then my last one, x minus 1's cancel out. I'll have plus 6. So it looks like what's going to happen here is it's going to give us a quadratic. So I have the potential for 2 solutions. So let's do our distribution here. I get 3x plus 3 on one side, and then x squared minus x plus 6 on the other. And so from there, I'm going to take and move the 3x and the 3 over, changing the signs. And I get 0 equals x squared minus 4x plus 3. And as I go to solve that out, I'm going to need to factor that out. So I need something that multiplies to a positive 3 and adds to a negative 4. So only time that's going to work out like that is when I have 2 negative numbers, and the only thing that multiplies to 3 is a negative 1 and a negative 3. That would add up to a negative 4. So factored out, 0 equals x minus 3 and x minus 1. So that means if x minus 3 is equal to 0, then x would have to equal a positive 3, or x could equal a positive 1. So checking, it's not allowed to equal a positive 1. That means this is not a solution. So in this instance, I'm only left with 1 that works out for me. And so my only solution here would be x equals 3. Okay, and on number 4, what I'll probably do is we'll find the common denominator, and then I'll leave you with an end shot of the rest of the solution of the problem so you can see how it works out and kind of do your best to work it out on your own and see if you get the same thing and can follow the process for it. So when I'm finding a common denominator, I first need something that multiplies to 15 and adds to negative 8. So I'm thinking 2 negative numbers. 15, 5, and 3, the only things that would work. And I've also got x minus 5, or minus 3 there. So that would split up into x minus 5 and x minus 3. So finding my common denominator, I have x minus 5, x minus 3. And that's there. I have an x minus 5 there, and x minus 3 there. So it's just those, which means x cannot equal positive 5 or positive 3. So the steps that I'm going to go through is to take and multiply all of these by the common denominator, which will cancel out both here and leave that. The x minus 5 would cancel out, so I'd be doing 3x times x minus 3. Then the x minus 3 on this one would cancel out. I'd be doing negative 1 times x minus 5. Then kind of go to combining them all together. So you're going to end up with an x squared from this middle part here, which means it's a quadratic. Everything will move to the left, and then we'll factor out that quadratic and figure it out from there. Okay, so I've gotten you down to canceling out when I multiply, leaving us with these three parts. And then when I combined like terms, I ended up with 3x squared minus 2x plus 3. Then I had a negative x plus 5 on the other side. So when I add x to both sides and subtract 5, then I ended up with 3x squared minus x minus 2. So just remember on these that when I'm solving them, I'll do the house top. So 3 times negative 2 gives me a negative 6. And so looking for something that multiplies to negative 6 and adds to negative 1, which should just be a negative 3 and a positive 2. So factored out, be x minus 3, x plus 2. But remember, since we multiplied, we're going to have to divide at the end. And so I take both of those and divide them by 3 to give me 3 over 3, which would be just x minus 1. And here it doesn't divide, so that 3 will move up in front of the x to give me 3x plus 2 equals 0. And so when I solve this out, x here would equal positive 1. But on the next part, end up with a fraction. Just going to be the opposite sign of this positive 2/3. But I subtract 2 from both sides, giving me 3x equals negative 2. And then when I divide both sides by 3, that gives me x equals a negative 2/3. And so since up at the top, 1 and negative 2/3 are not one of the ones that's not allowed to be, my answer would be x equals 1 and x equals negative 2/3. So x could equal 1 and negative 2/3. Both would be your answer.